Welcome. I'm glad you've joined me today to learn more about planning for authentic vocabulary development as a part of the sense-making process. I am Patty Works, and this video is brought to you by PIMSR, the Partnership Institute for Math and Science Education Reform. This is the first video in a two-part series on vocabulary development in science. As you participate in this workshop, this video can be used individually or with a grade level group or PLC. You'll want to have access to the following materials as we get ready to get started today. You'll want electronic access to the readings, and those are linked in the description box you see below the video. And then you'll need some sort of note taker of your choice, either an electronic document or paper and pen. Here are our objectives for this Science Vocabulary two-part series. In this first video, we'll learn how to plan for authentic vocabulary development within a phenomenon-driven lesson sequence where students are figuring out science concepts. And in the second video of the series, we'll work on starting to increase the vocabulary development tools and strategies in your teacher toolkit. During our time together in this video, we'll explore these questions. What can be problematic about learning science vocabulary or about pre-teaching science terminology? How is concept development related to vocabulary development? And how can conceptual science vocabulary be taught most effectively? Throughout the day here today, we'll sometimes use the word vocabulary, and other times I'll use the word scientific terminology or terms. So we'll use vocabulary and terminology interchangeably. So where are we heading in this video? Here's our agenda. First, we'll look at what do we mean by sense making in a science lesson. Then we'll make the case. When do we introduce science vocabulary and why? Next, we'll discuss the question, how do I plan for sense-making experiences in the classroom? And I'll walk you through a process that you can use as you plan. We'll use an example sequence to show how to plan for vocabulary development in the lesson series. And we'll take a brief look at what an interactive word wall might look like for a lesson sequence. So what is sense-making? It's a key innovation in NGSS and the Kentucky Academic Standards for Science. Science is fundamentally about making sense of the natural world. Sense-making is the conceptual process in which a learner actively engages with the natural or designed world, wonders about it, and then develops, tests, and refines ideas. So we often use that phrase to figure something out. When we're trying to figure something out, you're trying to make sense out of it. You're engaged in that process that we call sense-making. Essentially, it's actively trying to figure out how the world works for scientific questions and how to create or alter things to achieve design goals for engineering questions. I like this quote from the NGSS Achieve Workbook, which encapsulates the biggest shifts in NGSS. The difference in the verbs used in the NGSS tells the story. Gone is the conception of science education as an abstract recall of facts. Instead, we want students demonstrating proficiency in science by engaging in actual scientific practices. In this case, developing models, designing solutions, and constructing arguments. In the words of one standards author, the NGSS required that students move from demonstrating good note-taking skills to demonstrating true understanding of scientific practices, concepts, and core ideas. The resulting implications for classroom practice could not be greater. So just like our teaching strategies need to change as we're shifting to a discovery-centered style of teaching and learning, we also need to change how we teach students science vocabulary or terminology. Traditionally, science terms have been taught at the beginning of a unit. Sometimes that's called front-loading vocabulary. We've taught all the vocabulary that students need to know before we even dig into the text, lab activities, or discussions. But this can create a problem. Often students either don't memorize the words that we're giving them, which means we've wasted some class time, or they memorize a definition without really understanding the concepts behind the meaning. That can result in a bad outcome. Students may appear to understand what's going on because they're using the vocabulary, but they don't actually understand the concept when you probe farther. What's more effective is to have students actually engage with and explore topics with materials to develop vocabulary and then be able to use the words appropriately in models, arguments, explanations, and design solutions that they develop. So the vocabulary that our students are going to use as scientists in our classroom falls into two categories. Procedural vocabulary, and that's the vocabulary that students have to be able to participate in an investigation or experiment, such as the names of key tools and materials. And then we also have conceptual vocabulary. That's the vocabulary that students develop that consists of terms that describe complex ideas or processes like erosion, interdependence, electric current, adaptations, waves, or ecosystems. Although supports for students in ELA often talk about the importance of pre-teaching vocabulary, with science concepts, there's a reason to depart from this idea, and we'll talk about that today. Procedural vocabulary is that vocabulary your students need to have to successfully be able to engage in a learning activity. For example, if you were setting up an aquarium with your students, they might need to know terms like duckweed, guppy, tadpole, and graduated cylinder to be able to follow the directions and set up their small aquarium. Procedural vocabulary can be front-loaded or taught first. Think of it as putting a name to an object or an action so that students can follow directions. Conceptual vocabulary is a little different, however. This is vocabulary that involves complex ideas or processes, such as food webs, evaporation, or ecosystem. These terms are abstract and difficult to understand just by learning a definition. It's best to introduce them when students have already developed a context for the learning and they have a connection to the idea through experiences. So using the previous aquarium example, after students had populated the aquarium and observed it for a while, then they'll be better prepared to understand scientific terms like ecosystem or habitat, and then they can use them appropriately in conversation and writing. So why doesn't front-loading conceptual vocabulary work in science? Well, there are some differences. We're teaching the concept in addition to the term in science. And often students can't really understand the terms and their definition until they understand more about the concept that it's referring to. Students have to integrate new information into their existing schema. So that's why that pre-assessment of their science ideas is so important. You need to know what misconceptions you want to push back on with experiences to help improve their conceptual understanding. Students need to know and understand the meaning of a concept from multiple examples before we can meaningfully give them the scientific term and really expect them to use it correctly. But I don't want you to just take my word for this. Let's read a little bit about what some noted authors and researchers have to say about science vocabulary instruction. Let's make a case for what we're going to do in our classrooms and when it's best to introduce science vocabulary. The readings that you're going to want to locate have been linked below in the description box. First, you're going to want to find STEM teaching tool number 66, why you should stop pre-teaching science vocabulary and focus on students developing conceptual understanding first. And then there's a blog post by Peter Ahern called Is NGSS the End of Vocabulary? As you are reading the articles, just pause the video for a bit and look for text evidence to help you answer the 3 questions you see in the box. How can conceptual science vocabulary be taught most effectively? What can be problematic about learning science vocabulary or pre-teaching science terminology? And how is concept development related to vocabulary development? So once you pause the video, you may want to organize your notes to help answer those 3 questions. Feel free to go ahead and restart the video when you are ready to discuss a little bit with me, but you may want to do that with your group there at your school first. So when you're ready to move forward, just go ahead and restart the video. Now that you've read the articles and compared them with your colleagues, if you're working as a team where you are, let's dive into these questions together. So as you're watching the responses that you'll see on the screen, those have been made by other teachers, and we're going to share out our ideas as we look at theirs. So you want to watch and see, do you see any similar responses in your work? Do you notice any patterns? And do you see any ideas that these teachers noted in answer to those 3 questions that you might want to add to your list? The first question that we worked to answer was, how can conceptual vocabulary be taught most effectively? The responses you see here were selected from a group of teachers in our state who worked through this vocabulary development sequence previously. So I'm going to give you just a few minutes to silently read through those bullet points and see what their ideas were. Okay, so they've noticed things like how important it was to teach in the context of the learning, how vocabulary instruction should be interactive and have applications to the real world. We want to always incorporate the learning from hands-on experiences and help kids make relationships and see connections using tools such as concept maps. Again, inquiry, discussion, questioning, great way to build student vocabulary. And so we want to provide that scientific terminology when students are really starting to understand the concept and they now have that need to be able to communicate clearly and scientifically with precise language. So think about how these responses might compare to your own. Any ideas or patterns you want to add? The second question we addressed is, what can be problematic about learning science vocabulary or pre-teaching science vocabulary? Here's some thoughts other teachers had in response to this question. So take a few minutes and read those, please. I'm going to share and read that last one out loud. It's much more productive to support learners as they organically develop language, terms, and phrases that interpret and explain phenomena, rather than asking them to merely acquire the terms prior to instruction. I highlighted that last response as I thought that was a great summary statement. So how would you summarize the answer to this question? Perhaps in your small group, you'll want to stop the video and discuss some of your ideas and noticings from your own classroom. And last, how is concept development related to vocabulary development? Someone noted they go hand in hand. For kids to make meaningful connections, they've got to have developed some meaning to those conceptual ideas to match it with the vocabulary. Okay, we also notice that as concept development increases, vocabulary is going to increase. And we want to, of course, model using that scientific terminology as we're talking. Application and understanding help grow vocabulary knowledge. And as students are grasping concepts, they need to learn the new vocabulary that correlates with that concept. So what do we want to change in our approach to vocabulary development? If you would, please create a T-chart in your notes and think about this. What would you like to do more of? And what do you want to do less of? So pause the video now and think about any new ideas that you may have and how you may want to apply that to your teaching. You may have noted that it's more effective to provide students with exploration time and experiences to develop concepts, and then introduce the conceptual vocabulary words to give the students more precise language to describe what they've learned. And you may have thought you are going to be able to let go of a little bit of front loading of vocabulary because we know that it's less effective to front load that vocabulary, and that sometimes introducing the conceptual vocabulary at the beginning of a unit really can cloud the teacher's understanding of what students are learning throughout the lessons. They may just be word calling without really understanding the ideas. Next, we're going to take a look at how you can plan for sense making in a science lesson sequence. We'll be using a second grade example, but the process can be used with any age level. The sequence we'll walk through is not a long unit, and that's intentionally. We thought it might be easier to start thinking about this process with just a lesson series rather than a long, fully developed unit. So as you begin a lesson sequence, the first thing, of course, you want to look at is the standard or standards that you're wanting to address. Then you want to think about the key science concepts that you want students to acquire during instruction. Second, if you're the one developing the lessons offered yourself, you're going to want to select an engaging phenomena, something to really drive the learning and exploration and sense making. If you're using an established source of curriculum like OpenSciEd, NextGen Storylines, or Amplify Science, the driving phenomena may already be developed for you. Then you're going to need to think about what investigations, activities, and readings you are going to want your students to take part in as they collect evidence to figure out the phenomenon and the science concepts. Be sure to think about which science and engineering practices and cross-cutting concepts you'll want your students to be using in the sense-making process. So here's a graphic that shows steps in planning. After selecting the concepts to address and picking a phenomenon, then you're ready to sequence activities to help students explore, ask questions, collect evidence, and make sense of what they're learning, using those science and engineering practices and cross-cutting concepts as sense-making tools. After you've selected the investigations and readings, you'll want to notice any procedural vocabulary that students may need to know to engage in the first lessons. These terms may include objects and materials that they'll be using as they start to explore their focus question. Then next, you want to think about the conceptual vocabulary that you want students to develop over the course of the experiences. Then you can plan ahead and anticipate when concepts and associated vocabulary will be built during the lessons. Let's look at an example. Following the sequence that we talked about, first, you're going to look at the standards and think about what science concepts students will be learning. The performance expectation asks students to develop a simple model that mimics the function of an animal in dispersing seeds or pollinating plants. So to illustrate the process, we're going to look at a short lesson sequence thinking about a part of this PE, focusing specifically on seed dispersal. As students are learning about the interdependence between plants and animals, they'll be using several science and engineering practices in the lessons and multiple cross-cutting concepts as well. While the performance expectation highlights modeling and structure and function, we can use several other practices to help us develop conceptual understanding. During our short study of seed dispersal and plant and animal interdependence, I hope students are going to figure out the following science concepts. I want them to know that seeds can be moved in several different ways: by interaction with animals, either catching in fur or feathers and being moved that way, or by being eaten and moved when an animal deposits their droppings. That they may be blown by the wind, or they may float to a new place on water. Also important that they understand that animals have structures that can help move seeds to new places, and that seeds have structures that help determine how they are dispersed and how they're going to survive. So to engage students in figuring these concepts out, we need to choose a phenomena. It doesn't have to be a flash, bang, showy thing. Phenomena are observable things in the natural world that we can use science ideas to predict or explain. So that's a second step, finding a good phenomena. So here's an example of a phenomena that my students once asked me about. How do plants end up growing in places that we didn't plant them? Or how did this little flower seed ever wind up growing here in the crack of a sidewalk? How do those seeds get to new places? So that simple phenomenon can drive a series of learning experiences. Next, we want to think about what experiences we could arrange to help students find out about seed dispersal. As we're planning, we want to be conscious of building students' abilities to use the science and engineering practices and cross-cutting concepts to make sense of what they're figuring out. So just to show you what I might do with this lesson sequence, first I would gather some formative information to see what my students know by having them draw an initial model to show their ideas about how seeds might travel. They'll be sharing a model they construct to communicate their ideas. As they're doing this, they may be thinking about what caused the seed to move and what effect that had. They may notice structures that help to seed, like a dandelion seed, for instance, to blow in the wind, or they may be thinking of a spiky kind of seed that catches an animal fur. Having observed squirrels moving seeds, this student's initial model shows a squirrel burying an acorn. Next, in small groups or as a class, you'd want to let students share their models and describe their understandings. Then they can return to their model and add new ideas that they learned from the share-out. As students are sharing their models or writing about their ideas in their science notebooks, you may want to provide sentence scaffolds to support their idea sharing. We want to model how to communicate in scientific ways and help students become familiar with vocabulary that will help them do that. I'd encourage students to share questions and wonderings at this point that would help us guide the investigation. To help students have firsthand experiences with how seeds travel, I'd work cooperatively with the students to develop some investigation plans. Let's see if we can find out how different types of seeds might move. So I'd provide a variety of seeds like burrs, acorns, redbud seeds, and strawberry seeds and some different materials to use to try to move them. You might provide a straw to blow through a cup or tray with water in it, some fake fur or a stuffed animal that seeds could catch on, etc. And then after we discuss different things that we could test, we could talk about how to develop a fair test and some ways that they could record data with drawings or descriptions. After their data has been collected, groups can share their results. We'll analyze the data and construct a simple explanation or an evidence-based account, as it's called in primary grades. We might notice patterns in the data, cause and effect relationships, and the relationships between the structures of seeds and how they move. In their science notebooks, connections to writing and using vocabulary would be supported. Students could compose drawn or written simple investigation plans and record their results in a variety of ways, which we could later compare. Sentence scaffolds would help structure early scientific language use. After collecting new evidence from their investigations, students can go back and revise their models, adding some new learning to their initial ideas about how seeds might move to different places. So you can see this student has added some berries growing there on the bush, and now some of those are floating down the stream, being moved by water. And there's more descriptive detail that's been added to the model at this point. Now, we might collect more information from text and videos. Students would be obtaining, evaluating, and communicating information. You can see the chart they constructed evaluating how seeds were moved in the book, Planting the Wild Garden. As they looked for patterns, they might use mathematical skills to analyze some of the text. Different causes of seed movement could be explored in this nonfiction book. So with lots of new information from the text and media experiences, students would go back and add detail to their models. Notice that the student work is driven by the focus question: how do seeds end up in places we didn't plant them? The student has added dandelion seeds now blowing in the wind, seeds being carried on animal fur, birds eating berries, and depositing seeds. Now students are ready to use this unit vocabulary in writing an explanation to the focus question. As vocabulary has been developed, it would be added to an interactive word wall. Word cards can be written and illustrated by students or written by the teacher and paired with visuals created or found by the class. They've used evidence from investigations and text to support their ideas about how the seed might have moved. So here you see some sample explanations students might come up with. So now we're ready to look at how to think about vocabulary development in the lesson sequence after we have planned our experiences. As I was planning in this sequence, I would next want to think about what vocabulary I'd like students to pick up from those experiences during the unit. So thinking through the lessons, I decided that these are the words I thought students would acquire. I know it looks like a lot for second grade, but you'll notice that there are several words that have to do with the science and engineering practices, like model and investigate, and some that relate to cross-cutting concepts like pattern and cause and effect. These words would likely have been used previously and might be words that stay on the word wall all year long. Now I'm going to think through the lessons and see where would I think children would likely be exposed to these words, and it would be a natural place to include them and add them to the word wall. So here you see the bullet points show the lesson experiences that students just had in that sequence, where they were developing initial models, revising their models, adding firsthand experiences, revising models again, and then reading text and using media for more information. What I've done is just gone back through that word list and thought about, as kids are talking about their initial models, what words do I think I might hear students using that we want to record and add to the word wall? If those words don't come up naturally in conversation, there'll be plenty of places that you can add them later on. Certain words may be used earlier or later in the sequence, just depending on student questions and ideas. So this is really variable based upon the class. Okay, so now we're going to take a look at what I anticipate a word wall might look like that we would develop during that sequence. In video 2, we're going to talk a lot more about developing interactive word walls that students can use in their discussion and writing. This word wall would not be something that's all put up at the beginning of the sequence, but it would be built during the course of the lessons as students need and are going to use the scientific terminology. When planning for a word wall, you'll learn that you want to group words into categories so students can find them easily. You notice that there are real objects, drawings, and pictures that help illustrate the vocabulary. You may choose an organizational pattern, like a graphic organizer, to house the word groups. I put our focus question that guided our learning throughout the sequence right in the middle to help students figure out about the phenomena. The groupings along the bottom show different ways that seeds are dispersed by wind, then by water, and all the words over here have to do with animals and their interactions. So the word group up on the top is where I just put general vocabulary words that we were using throughout the unit about seed dispersal. And then up on the top, I added words in blue that had to do with the science and engineering practices we use, and in green with the cross-cutting concepts in the top right. The practices and cross-cutting concepts words might stay up all year as we were building vocabulary in those areas. So as we close today's session, a couple of key points to remember. Terminology and vocabulary is really important, and conceptual vocabulary should be specifically developed in the context of the learning. Please encourage your students to share their ideas using their everyday language, and then realize that you're moving towards that specialized language as they go. We want students to develop specialized language to be able to be precise in communicating about their science ideas. And the science terms are often complex. They're definitely part of specialized language. So let's look at our session goals for the vocabulary series again. In this session, we learned how to plan for authentic vocabulary development within a phenomena-driven lesson sequence, where students are figuring out about science concepts. And we look specifically at the difference in when to introduce procedural vocabulary and conceptual vocabulary. In video 2, we're going to take a look at some high-impact vocabulary development tools and strategies, which you can add to your teacher toolkit. So as we close out the day, maybe take a moment to revisit your T-chart individually or with your small group. Anything you want to add to the more of or less of columns? Focus on developing vocabulary more effectively in the course of the learning, and let go of that idea that we have to pre-teach all science vocabulary. Think through a sense-making sequence and intentionally plan for authentic vocabulary development that's embedded into the learning. And we hope you'll join us for video 2 on high-impact vocabulary strategies. Video 2 in this series will focus on strategies that help make vocabulary words stick, and ways to help students use them in writing and discussion. We'll look at some different techniques and activities for authentically integrating vocabulary into writing and student discourse, and we'll take a close look at planning to use interactive word walls. So thanks again for joining us today, and look forward to working with you on video 2.